Hi friends, today we are discussing about Git. Git nothing but a version control system. What is version control system? Version control system is a software that helps software developers to work together and maintain a complete history of their work. We can discuss some functionalities of version control system. It allows developers to work simultaneously, does not allow overwriting each other's changes, maintain a history of every version. Types of version control system. There are two types of version control systems. One is centralized version control system and another one is distributed version control system. Coming to centralized version control system. Centralized version control system uses a central server to store all files and enable team collaboration. But the major drawback of centralized version control system is its single point of failure, that is failure of the central server. Unfortunately, if the central server goes down for an hour, then during that hour no one can collaborate at all. And even in a worst case, if the disk of the central server gets corrupted and proper backup has not been taken, then you will lose the entire history of the project. Then coming to distributed version control system. Distributed version control system clients not only check out the latest snapshot of the directory, but they also fully mirror the repository. If the server goes down, then the repository from any client can be copied back to the server to restore it. Every checkout is a fully backup of the repository. Git does not rely on the central server, and that is why you can perform many operations when you are offline. You can commit changes, create branches, view logs, and perform another operations when you are offline. Then then coming to advantages of Git. It is a free tier and open source, fast and small, implicit backup, security, no need of powerful hardware, a rare bunch. Coming to free and open source. Git is a open source. It is available freely over the internet. You can use Git to manage proprietary projects without paying a single penny. As it is an open source, you can download its source code and also perform changes according to your requirements. Then coming to fast and small. As most of the operations are performed locally, it gives a huge benefits in terms of speed. Git does not rely on the central server. That is why there is no need to interact with the remote server for every operation performed. The core part of the Git is written in C, which avoids runtime overheads associated with the high level languages. Through Git mirrors entire repository. The size of the data on the client side is small. It illustrates the efficiency of Git at compressing and storing data on the client side. Coming to implicit backup. The changes of losing data are very rare when there are multiple copies of it. Data presence on any client side mirrors the repository, hence it can be used in event of crash or disk corrupted. Security. Git uses a common cryptographic hash function called secure hash function to name and identify objects within its database. Every file and commit is checksummed and retrieved by its checksum at the time of checkout. It implies that it is impossible to change file data and commit message and any other data from the Git database without knowing Git. Then coming to no need of powerful hardware. In case of centralized version control system, the central server needs to be powerful enough to serve requests of the entire team. For smaller teams, it is not an issue, but as the team size grows, the hardware limitations of the server can be performed bottleneck. In case of distributed version control system, developers don't interact with the server unless they need to pull or push changes. All the heavy lifting happens on the client side, so the server hardware can be very simple indeed. Then coming to earlier branching. Centralized version control system uses a chief copy mechanism. If we create a new branch, it will copy all the codes to the new branch. So it is time consuming and not efficient. Also, deleting and merging of branches in centralized version control system is complicated and time consuming, but branch management with Git is very simple. It takes only few seconds to create, delete and merge branches. Then coming to workflow. The working directory is the place where files are checked out. In other centralized version control system, developers generally make modifications and commit their changes directly to the repository. But Git uses a different strategy. Git does not track each and every modified file. Whenever you do commit an operation, Git looks for the files present in the staging area. Only those files present in the staging area are considered for commit and not all the modified files. First step, you modify a file from the working directory, then you add these files to the staging area. After that, you perform commit operation that moves the files from the staging area. After push operation, it stores the changes permanently to the Git repository. Then coming to Git terminologies: blocks, trees, commits, branches, tags, clone, push and pull. Coming to blobs. Blob stands for binary large object. Each version of a file represented by a blob. A blob holds the file data but does not contain any metadata about the file. It is a binary file, and in Git database it is named as hash function of that file. In Git, files are not addressed by names. Everything is content addressed. Then coming to trees. Trees is an object which represents a directory. It holds blobs as well as other subdirectories. A tree is a binary file that stores reference to blobs and trees, which are also named as function of the tree object. Then coming to commits. Commit holds the current state of the repository. A commit is also named by hash. You can consider a commit object as a node of the linked list. Every commit object has a pointer to the parent commit object. From a given commit, you can traverse back by looking at the present pointer to review the history of the commit. If a commit has multiple parent commits, then that particular commit has been created by merging two branches. Then coming to branches. Branches are used to create another line of development. By default, Git has a master branch, which is same as trunk in Subversion. Usually, a branch is created to work on a new branch. Once the future is completed, it is merged back with the master branch and we delete the branch. Every branch is referred by head. Then coming to tags. Tag assigns a meaningful name of with a specific version in the repository. Tags are very similar to branches, but the difference is that tags are immutable. It means tag is a branch which nobody intends to modify. Once a tag is created for a particular commit, even if you create a new commit, if it will not be updated. Usually, developers create tags for product release. Then coming to clone. Clone is a operation creates the instance of the repository. Clone operation not only checks out the working copy, but it also mirrors the complete repository. Users can perform many operations with this local repository. The only time networking gets involved in when the repository instances are being synchronized. Then coming to push. Push is a operation copies changes from a local repository instance to a remote one. This is used to store the changes permanently. It is the Git repository. This is same as the commit operation in Subversion. Then coming to pull. Pull is an operation copies the changes from the remote repository instance to local one. The pull operation is used for synchronization between two repository instances. This is same as updated operation in Subversion. Then coming to life cycle. First, you clone the Git repository as a working copy. Then you modify the working copy by adding or editing files. After that, you also update the working copy by taking other developers' changes. You review the changes before commit. Then you commit changes. If everything is fine, then you push the changes to the repository. After that, after committing, if you realize something is wrong, then you correct the last commit and push the changes in the repository. Thank you.